Welcome to the next in the Naze32 series. In this video we're going to be adding an on-screen display to the Naze32 using this great piece of technology which is called a MinimOSD. Now I've added these boards to other flight controllers in other video series and you can actually see here one that we did for the multiwii. And as the Naze32 shares an awful lot of technology and code with the multiwii, we can do the same on here, but it's a little bit more interesting. A couple of reasons. One is we don't have all the same ports, so we have to have the pins going to different places, and there's an extra bit of soldering that we have to do too. First of all, it's probably worthwhile taking a couple of minutes to explain what an on-screen display is and why you'd want one. An on-screen display is really useful when you're flying first-person view or you're looking at the display of a camera that's mounted on the craft. So typically you'll have a camera mounted on the front of the model and it'll have a transmitter somewhere that's sending that video back to some kind of ground station or goggles. This board sits in between, and on top of the video that's coming from the camera, it overlays critical information from the telemetry port on the Naze32. And that include things like, if you have the GPS on there, GPS coordinates, headings, speed, altitude, battery voltage, and other things as well. So it's rather like looking at the cockpit of a fighter craft. And the nice thing is that you can turn it on and off, and also change what you want to see in the display. So you can have it really cluttered with artificial horizons and altitude meters and all kinds of things, or you can just have it really simple where you have the battery voltage and a direction to home arrow with the distance back there too. There are a number of options for the firmware for things like the MinimOSD. I'm going to go through the one that's most commonly used here, and then what I might do is do a quick tip later on that'll show you alternatives. So we are going to cover in this video how we are going to set it up, what we're going to need. Just to warn you, you're going to need one of these things, an FTDI connector. If you are a multi-wii person or you have Arduino kit, you'll have one of these in the bag somewhere. We need this to program the board with the firmware. Then we'll actually get on and we'll get the firmware, we'll download it, then we'll actually install everything onto this board so it is ready to be plugged in. Then we will plug it into the Naze32, and then we'll plug it into the camera on the other side. We'll talk about the power options. There's a lot of confusion about these boards, about how you power them. It's actually pretty straightforward if you just obey a couple of rules, and I'll cover what those are. And then we'll finally do a little bit of configuration using the GUI to show you how you get things on and off the display, and then a quick demo at the end. So first thing we need to do is we are going to have to think about flashing the firmware. So what I'm going to do is clear the decks and we'll start looking at the software we need, and we'll need the board and we'll need our FTDI adapter. So before we plug the board into the FTDI connector, we're going to bridge a couple of connectors. On a lot of the boards that I've ordered, these have already come pre-done. On this one, interestingly, it hasn't. And on the board, there is these two pads right here that have got separate little blobs of solder on. And on the back, there's another two pads here, which have got nothing on at all. And you can see they're kind of made to bridge this ground plane with this ground plane on the back, and on the front the way it works is this connects this 5-volt system to this 5-volt system up here as well. Now we'll talk about this later, so don't worry about it for now, but just check that your board has a blob of solder that connects these two pieces on the front and a blob of solder that connects these two contacts on the back before we plug in our FTDI. So now we've got those little solder things bridged on the board, we can power everything from the FTDI adapter. Now the firmware we're going to use here, we have a couple of choices, but I'm going to use this one first, is this KV Team 2.3. You can get it from code.google.com/p/rush-osd-development. We'll download this in a second, we'll have a look at it. Another version of the code that I've used with great success with the multiwiis is this one here, which is the multiwii-osd. In my opinion, it has a slightly cleaner heads-up display for FPV, and I prefer that one, but we are going to do this one first as it's one that is most commonly referred to in forums and video posts. So the first thing we need to do is download this thing. So we're going to click on download 2.3. It'll then go to the Google Drive, which I'm not a huge fan of. We have to then click on MinimOSD 2.3 again. Rather than asking us if we want to save it, it'll come and show us what we've got. Then to actually save it, we have to click on this bit here to download, and then it'll ask us where we want to save the file. Now, I've already saved the file on to the desktop, so let's have a look at that. That's the actual zip file as it comes down, and you can see there's a couple of directories in it. I have unpacked that into this folder. So there we have the two main directory structures. The first one is the graphical user interface that we're going to use to configure the settings that we want on the on-screen display, and the second is the actual firmware that we need to flash to the board. Now, to flash the firmware, we are going to need to use the Arduino program. If you are an Arduino or a multi-Wii fan already, you'll already have this. I'll put a link in the description below if you need to download it. This is a great piece of software. It's amazing how often you use this. We need to open, if we go to desktop, we go to the KV team folder, we go to the OSD folder that we were looking at before. This is all the firmware files. We want to click on KV team OSD INO. And there is the software. Now, in config.h, these are all the configurable parameters that you might want to change. I'm not going to go through them because these defaults work beautifully on 2.3 with the Naze32. So to flash the software to the board is pretty straightforward. What we have to do is plug the FTDI connector into the 6 pins at the end of the MinimOSD. You'll notice normally that any FTDI style connector will be labelled with kind of a black and green side. You just match those up on both the FTDI connector and the board itself, and then plug a USB cable into the FTDI connector and into the PC. Make sure that that is the COM port that is selected, and for the board type, make sure that you have Arduino Pro or Pro Mini 5 volt 60 megahertz with 18 mega 328 selected. Once you've done that, then you're going to click on upload. It'll compile the software and then push all of that firmware up into the board, and you've done one of the hardest bits. Okay, next thing we need to do then is, while we still have the FTDI board connected to the computer with USB cable, we need to start the GUI and have a look and make sure that, one, it can see the board and it can see that it's happy, and secondly, we can start configuring the pieces that we need to. So let's do that next. Now, we still haven't connected the MinimOSD to anything else yet. We have just plugged it back into the computer just to reboot it to make sure it's a nice clean start of the MinimOSD. Next thing we're going to do is see how it feels. So we're going to go into KV Team GUI this time. We're going to go into the Windows 32 directory. Nice to see there's a Mac and Linux version 2. And we're going to run the program itself. It can take a second to start if it's the first time you've run it on your machine for a while. Once it's up, it's going to look a little bit like multiwii-conf, again, which is a very similar kind of interface for multi-Wii fans. But what it'll do is it'll allow us to connect to the board on the left-hand side and show us all of the configurable options that we have on the display. So here we can see COM7, which is the board we're connected to. I'm going to click on that, and everything should go green as it starts to communicate. Fantastic. So now we can see that it all looks in pretty good shape. There are a couple of things that we need to do first of all. The very first job is to actually change the fonts. Now, the fonts are actually held in EEPROM on the MinimOSD, and they can occasionally get corrupted. You can get a little EEPROM clearing tool that will actually completely delete all of the contents, but it's always a good idea, particularly if you're changing different versions of your on-screen display software, to upload the fonts. So let me start that running and then I can explain the rest of the screen, because that takes a couple of minutes to do. So first of all, we're going to load the fonts that we want. There's two types of fonts with this on-screen display software. Big and small, surprise, surprise. So depending on how big you want them overlaid onto the screen, you can choose. I'll pick small and click open. It'll think about it for a second and tell me that it's uploaded the fonts, and then we'll actually be able to edit them. There we go. So if I click on edit font, there are all the fonts that are available. So you can see the direction to home arrows, the half, you can see the numbers, they're relatively small. You can see how it counts disarmed. So if you really wanted to, you could, if you wanted to change any of this stuff, you could. Once you have the fonts the way you want them, large or small, the next job is to upload them into the EEPROM. So we're going to click on upload, and then it'll start counting. So here they go, they're slowly going up into the MinimOSD. You can see the transmit is blinking away, and that's going to be going for a while. It's going to have to upload all 256. But while it's doing that, that's a great chance for me to explain what the rest of this is all about. Obviously we want to the board type, we want Minim, and this is kind of saying, where do you want this information to come from? At the top of most of these there's an ADC or multiwii switch. Now the reason for that is that you can either have analog digital converters directly connected to things like the main battery voltage, or you can actually get that information via the telemetry data that's coming out of the Naze32. So I'm going to have as much of that as I possibly can coming out of the Naze32. So I'm not going to use any of the directly connected analog digital converters, because one, you need a special board or a fantastically fine soldering iron to do that stuff. GPS setting, I'm actually going at the moment to turn those off, just because I don't have the GPS installed on this board yet, but when I do, I can turn those back on here. The unit and video, I'm in the UK, so it's PAL. All my systems are set up for PAL, so I'm going to keep it that way round. And imperial or metric, do we want meters, kilometers, or do we want to use what the UK or the elder people in the UK and North America like to use, feet, inches and miles. I actually have got used to flying in metric, so that's fine. This all looks good to me. So we're almost at the point where the fonts are finished. Once that's done, I'm going to then write the settings back to the board so that all these little changes that I've made up here are remembered, and we can move on to the next bit. The fonts are just finishing. There we go, fonts are done. So I'm going to write my changes to the board. Okay, that looks really, really good. So I'm going to close the COM port, and the next thing we're going to have to do is actually solder a couple of extra pins onto the Naze32 and start cabling things up. But first of all, let's talk about why we have had to bridge those two little bits and pieces on the MinimOSD before we plugged in the FTDI connector. And let's talk about the power system, because we're going to need to understand that before we start cabling things together. So here's a diagram of our friend the MinimOSD. The FTDI connector is on the left that we've just plugged everything into, and on the right are the two connections, both in and out, for the video. One will go to the camera and the other one will go to the video transmitter. If we actually look at what is on the board, the main two chips are the Atmel 328 CPU, which is why we chose the 32L in the Arduino program, and the other one is a Max 7456 chip, and that job is to overlay the on-screen display information on top of the video that's coming in from the camera. Both of those are 5-volt chips. First plus 5 volt area is the one that the FTDI powers, and that powers all of the Atmel processor and all of the other components, and it stops on one of the pads that we bridged with a piece of solder. The second plus 5 volt system is the one that powers the Max chip, which is doing the on-screen display magic. The third part is a 12 volt system that is connected to the 12 volts in and out of the camera setup. Now, the way that works is that there is actually a voltage regulator that steps down the plus 12 volts that it can see on the camera side to 5 volts that it will run the Max chip for. The danger with this is that the voltage regulator that's used on the MinimOSD boards can have problems and get very hot and overheat and damage the board and potentially blow the Max chip as well. So the easiest thing to do is actually to join those two pieces as we did before with two blobs of solder, and then those two 5 volt areas that run both the 328 processor and the Max chip are all connected. So if you put 5 volts in the left hand side, then it powers the entire board. What that means is that you don't put any 12 volts on to the video out, but that's a very small price to pay for a faultless operation and no problems having to worry about video. So now we know that, and that's how it works. So the two golden rules are: make sure that you've bridged the two blobs with solder and don't connect 12 volts to the output pins, then you'll be good. We can move on to the next part and talk about how we're going to connect the board to the Naze32. The thing you have to do here is solder two additional pins into the center of the board. Now, we didn't do this in the initial config and setup because I thought, to be honest, the MinimOSD would want to be later videos, but it's one of the first things that's arrived in the post. You have to put these two pins in the middle because this is where the telemetry data is pumped out of the Naze32, whether you want it or not. You don't need to change any of the code on the Naze32 for this to work. It will automatically be sending out telemetry data via these two pins once they've been soldered on, and those two pins then become vital in how we connect the MinimOSD to the actual Naze32 itself. So before we go to the table and we actually start plugging everything in for real, let me just go through the principle in a couple of diagrams just so it's crystal clear. Here's the Naze32 on the left and the MinimOSD on the right. First thing we need to do is we need to power the MinimOSD. So we need to connect the ground pin from the ground output on the FTDI connector up into one of the spare ground pins that we can get our hands on the output row for the motors and ESCs. Next thing we need to do is we then need to plug plus 5 volts. We need to power the MinimOSD, and again we can do that from a spare plus 5 volt rail, one of the middle pins of the motor out. If you haven't got a spare pin, if you're running 6 motors, then you'll need to splice these into the board or pick them up from one of the other pins. Next thing then we need to do is we then need to connect the transmit to receive and receive to transmit between the Naze32 and those two new pins that we've soldered onto the board and the transmit and receive inputs and outputs on the MinimOSD. Once we've done that, then we are ready to connect the camera on the other side. So let's stop there and I'll show you what that looks like in real life. So here we have it ready to do it in real life. I've taken the liberty of actually plugging in each of the cables on the MinimOSD. Underneath it very clearly labels which pin is which, but yours isn't. From the green end it goes transmit, receive, plus 5 volts, ground and black. I have the black cable plugged into ground, the red cable plugged into plus 5 volts, that's just convention, it makes it easier. The yellow cable is plugged into receive, and the green cable is plugged into transmit. So we need to plug these cables now into the other end. First two we're going to do are power and ground, the red and black cables. So we're going to plug the black cable into one of the ground pins from the spare motor out. We're going to plug the red cable into the middle connector because that will give us 5 volts. That is the power system done. Then we need to connect the yellow pin, which on the MinimOSD end is plugging into receive, into transmit. which is that pin there. And then we need to plug the last cable into the other spare pin. And there we have it. That is all wired up, ready to go. So again, we have the power coming from one of the spare motor out sockets, and we have receive and transmit crossed over. So receive on this end is a transmit here, and vice versa. One of the common things easy to get wrong is get these two cables the wrong way around. If it doesn't work, the first thing I do is swap the cables receive transmit over on either the MinimOSD or the Naze32 to see if that is the problem. It usually is 9 times out of 10. Okay, now we've done that bit, we need to talk about how we're going to connect this all up into the camera. So the last part now is to connect the MinimOSD and put it in between the camera and the transmitter. And that's relatively straightforward, but again we just have to be careful, as we know about from the power system, we don't put any voltages on these pins, just ground and signal. So the first thing we're going to have to do is unplug the camera from the video transmitter, because the MinimOSD is going to go in between those two. Now on the back of the MinimOSD, you'll notice that it very clearly says, put it that way around, you better see it better, which is the ground, which is the voltage, and which is the video in and out. That is video in and that is video out. Be very careful when it's a right angle pin, it's easy to get confused. So video out is on the bottom. So what we'll do is we'll use a quick little cable to connect the transmitter to the video out pins on the MinimOSD. Be very careful you're getting ground and signal the right way around. You'll notice though in this instance what I've done is it's only the ground and signal cables that are connected. I've not connected the plus 5 volts. Next thing we need to do is then connect the video inside. So we need to connect again the negative and signal wires and then plug that into the camera, being very careful with polarity. So we're making sure that black goes to black, red to red, and keeping it the same. And then to make sure that the 5 volts can make it from the video transmitter out into the camera, we're just going to connect these two 5 volt leads together. And obviously when we install it in the craft, we'll cover this with heat shrink so that it's not going to cause any shorts. And there we are, that's it done. So let's look at how that looks in a diagram form, and it'll make a bit more sense. So what we've done here is we started with a very simple configuration. We had the video transmitter connected directly to the camera. What we have done is we have put the MinimOSD in the middle of that so that the video coming from the camera now goes to the video in connector on the MinimOSD, and the video out goes to the video transmitter. You'll notice that the red wire from the video transmitter going down to the camera doesn't go through the MinimOSD as we've done it on the bench. It's just easier that way, and it avoids all of those power problems that we've talked about before. So now the last thing we need to do is power this on and have a look at it through my ground station, and you can see it in action. So here we have the system all powered up. So we have my Diversity Blackpearl 7-inch Diversity receiver, and here we can see the on-screen display. We have the MinimOSD with both lights lit, which is showing that both of the 5 volt circuits are alive and well. We have our Naze32, and we've put the camera at the back pointing at a piece of black cloth. The reason is it's easier to see the overlay with the smaller screen font that I have picked. Now, to prove that it's actually connected and working, if I tilt the Naze32, you'll see that the artificial horizon on the on-screen display is changing. And also, if I just take that bag away, you'll see that that's the actual camera that it's working on. Occasionally, you'll find that the MinimOSD won't start properly, and you'll just have the video with no overlay. If that's the case, don't worry, there is a little reset button on the MinimOSD. If you just press that briefly and let go, then it'll reinitialize and restart. you'll get the welcome bits and pieces on the screen, and then it'll kick into life and it'll all be working. So that is the trick. If you find that you don't have the display, two things: make sure that receive and transmit are in the right pins on your Naze32, and also hit the reset button. It might have not quite initialized before everything was ready. So hopefully that's interesting for those of you that have the Naze32. Now you know how to connect the MinimOSD and to have a fantastic little fighter pilot overlay on your FPV system. So thank you for watching. Please like, subscribe, and as always, happy flying.